All right, so we'll go ahead and get started. Thank you for everyone for joining for our opening keynote with Lois. So she is the Director of Conservation Evidence at the World Wildlife Fund. Lois's research focuses on understanding the social and ecological impacts of conservation, especially with really complex social and ecological systems. She's led WWF's conservation evidence portfolio that seeks to generate, synthesize, and integrate evidence on the impact of conservation interventions into policy and practice. Before working with WWF, Lois conducted her PhD research in northern Kenya, which is super cool. So today, she's going to talk about how to save the planet one data point at a time. And with that, I'd love to welcome you, Lois.
Wonderful. Thank you so much. It's a pleasure to be here, and I'm really excited to see what you all get up to over the course of this event. So how do we save the planet, and what's the role of data and data analytics in all of that? So as you all probably are aware, nature and the planet is in trouble. Since 1970, about 60% of species around the world have declined by, about 4,000 species across the world have declined by about 60%, which is a pretty dramatic reduction in population. But the pace of that change, far from kind of letting up, is accelerating, and we are living in what is commonly described as a great acceleration. Trends in patterns in climate systems, in earth systems, in human use of resources, in consumption are rapidly increasing. And so what do we do about that, and how do we bend the curve, reverse this trend in the decline of nature, mitigate global climate change, and engineer a sustainable and socially just future amidst this crisis? And we think about that in the way of how do we bend the curve for nature and for people and change the trajectory of the planet that we've seen over the past century. But to do that, we need evidence on how to do it, because complex systems change isn't something that we can just engineer without evidence. And so we need to understand some different types of evidence in order to act. We need to understand what the problem is and have data that tells us what the global trends are, what the local trends are, and what that all means for the trajectory of the planet. We need to have data on the potential set of solutions and what they might do for us, both in terms of their environmental impact, their social impact, the impact that they have in terms of the direction, the magnitude of the impact that they have, as well as the sort of equity of the impacts that they have. And we need to know that the solutions that we're thinking about will work in the specific context that we plan to apply them. It's not enough to say intervention X works in place Y when really we're interested in place Z. And so we need to have really context-specific data that tells us something about the problem and the solution that we're proposing. And therein, we face a paradox. And the paradox is that we live in a world overflowing with data. I don't know how many of you have heard about Buckminster Fuller's expansion of knowledge theory that says that, up until the 1900s, knowledge base was expanding approximately once a century, and estimates now suggest that knowledge is expanding or doubling within days. And so in a world where we are bombarded with a fire hose of information, how do we make sense of it? And how do we recognize the critical knowledge gaps that we still have that limit our ability to act effectively and with equity? And this paradox manifests in two ways. And the first problem that we face is that you can't manage what you can't measure. And this is an old sort of business advice paradigm that has borne out again and again and again, and has a real ring of truth to it. So let me give you an example here. So global agreements, things like the Sustainable Development Goals, the Paris Agreement for Climate Change, the Convention on Biological Diversity, they shape our global priorities, our government policies, the priorities of nonprofits, and so forth, and they direct billions of dollars in public expenditures. The Millennium Development Goals, which were the predecessor of the Sustainable Development Goals, catalyzed rapid progress on a number of fronts. They weren't wholly successful, but we did see rapid progress on some key indicators, including on extreme poverty, on the enrollment of primary age school children in education, and on the global mortality ratio for mothers. And estimates suggest that the Millennium Development Goals saved somewhere between 20 and 30 million lives. But there's a rub to this. And that is that the amount of data and evidence that decision makers had for specific goals predicted how much progress that they made. So those goals that had strong evidence that enabled decision makers to create strategies, to adapt their strategies and move forward, demonstrated significantly higher progress than those goals where evidence was patchy or non-existent. And those patterns persist even after controlling for all of those factors that you might think influence progress on these kinds of global goals. So evidence matters. The amount of evidence that we have significantly shapes our decision-making. And that trend, that pattern that we see again and again, is particularly worrying when we think about the current Sustainable Development Goals, which lay out a global agenda by 2030 that identify the world that we want to see. And 1/3 of the proposed indicators under the Sustainable Development Goals, and that are relevant to the work that WWF does in the environmental space, are what we call Tier 3 indicators under the Sustainable Development Goals, which means that they have no data available to inform decision-making, and even no agreed methodology that could help us get to a place where we could have data that could shape a decision. And so when we look at the pattern of the balance of the information that we have, as shown here by the filled white bars, what you begin to see is that if this trend of more evidence meaning more progress by 2030 is borne out, we will live in a world where we have affordable and clean energy, clean water and sanitation, but we will live in a world with significantly less life on land, life on water, and so on. This is a huge problem for the world. We need data in order to make decisions. To give you an illustrative example, SDG 15, which speaks about life on land and sets targets for things like the extent of forests. For nearly 10% of the indicators involved in that development goal, there is no methodology available. The majority of indicators that we have focus on extent alone. Few indicators focus on the actual health of the ecosystems that we're talking about. So how do we make decisions when we've got one hand tied behind our back because of lack of data? This same phenomenon doesn't just play out at a global level, it plays out in the day-to-day decision-making that we make when we try to implement conservation interventions. So what you're looking at here is some work that WWF's global science team has been doing over the past few years to create a dashboard that allows WWF to understand the impact of its work on the world in the context of global goals and to be able to track those changes. And this was put together by a team of interdisciplinary scientists who have a really good handle on the data that is available in the world. And what emerges from this, and what shocked us and surprised us, was the extent of the data gaps, even on the most basic phenomena that we see in conservation. And some of these data gaps include things as seemingly simple as how do we measure whether forests are degraded or not? How do we measure the amount of coral reef that we still have in the world? How do we measure our ability to adapt to climate change? There are a whole suite of data sets where we have data, but they're not actively updated, meaning that they have relatively little use for ongoing decision-making. They tell us something about the state of the world as it was, but they don't tell us anything about the state of the world and how it's changing. And these include basic attributes of protected areas, which are a cornerstone of conservation. Things like how representative they are of different ecological regions in the world. We don't have data on where there are hydropower and infrastructure projects, which gives us limited ability to detect changes in freshwater connectivity, which is really important for freshwater species. And we have large chunks of data missing for things like wetland extent, water quality, the presence of community conserved areas. And all of this begins to build into a picture where it's really difficult to make decisions about what to do and where to do it, because the picture that we have is so incomplete. Another problem that we have is really beginning to understand the impacts of conservation interventions at a micro scale. So up to now, I've been talking about how do we understand the impact of conservation at the macro scale, toward progress towards global agreements. But then when we look down and think about how do we tell what's happening on the ground in a specific place at a specific time, there again, we run into challenges, because the data sets that we need to do that are high resolution, both spatially and temporally. We need information across a range of indicators in both areas where conservation occurs and areas where it doesn't. And so one of the things that we've been trying to do over the past few years is to think about how we bring together alliances and sort of groups of actors to begin to collect and synthesize that data together so that we can learn about the impacts that we have on the world more rapidly and more effectively. And so a group called the Alliance for Conservation Evidence and Sustainability has formed, and it is trying to examine the impacts of community-based conservation projects around the world, bringing together the work of multiple nonprofits and university partners to try and tackle this question at a speed and scale that none of us could do alone. And this is beginning to show some results. So for example, in Indonesia, where we're really keen to understand how the establishment of marine protected areas influences human well-being by changing patterns in fish catch, by hopefully increasing the biomass of fish on coral reefs, we can begin to unpack the impacts that we have, both by different marine protected areas, by different social groups, to begin to provide the resolution of information that decision makers really need to adaptively manage on the ground. The second major problem that we face is that we may be drowning in data. So the paradox that we live in here is that we have critical knowledge gaps in some places, and elsewhere, we're drowning in data. And this quote is one that was published in the Washington Post about 5 years ago in response to a publication by the World Bank. And the World Bank did an internal study looking at the number of times that reports published on their website had been downloaded or cited. And a full 10% of reports on the website had never been downloaded, never been cited. And so one begins to ask, with all of this information out in the world, do we already know the answer? Just nobody's read it yet. Nobody has synthesized it in a way that a decision maker can actually use and think about and feed into a decision. So we're drowning in data in some respects and starving in others. How do we deal with that paradox? And I think the critical point here is that to be useful, knowledge and evidence, data, has to inform a decision. It's not enough for us to just create information. It has to actually make its way into the hands of the person who's going to take action. So we often think about here is the evidence base, the full sphere of knowledge that exists, being a much larger pool than the considered evidence base, that which actually gets into the decision-making filter of any decision maker anywhere. And this can apply when you're buying your cup of coffee in the morning. The evidence base that you have around whether or not to use a reusable cup or to get one of those paper cups is much larger than the evidence that you might actively consider in that decision, because the evidence that you're considering in the decision is that of which you are aware and able to synthesize. Similarly, evidence isn't the only thing that goes into your decision-making. Your emotions, your beliefs, your values, the things that you have read and the policy narrative that surrounds you influences the decision that you are going to take. So it doesn't matter inherently that you know that a reusable cup is better for the planet if everything around you is telling you that, in fact, just use a paper cup because it's quicker and easier and the kids are screaming and you just need to go get your cup of coffee. This phenomenon is really important because it speaks to how we need to manage evidence and use it to drive decision-making. It's not enough to create it. You have to put it and synthesize it in a form that is appropriate to the decision maker. And it has to be appropriate in terms of its context, its presentation, its format, the types of information. And so this is where the science of decision-making becomes almost a dark art, because what you need to do is deeply understand what decision is going to be made at the end of it and what are the influences on those decision makers. What evidence do they consider credible, not what do you consider credible? And so this is where we get into decision support tools and the ability to rapidly synthesize evidence into a format that can make decisions. And here are just two examples. So on the left, you're looking at a table that might not look like much, but is in reality the product of thousands of hours of work by Madeline McKinnon and Samantha Cheng, who led a group that sought to map the evidence base for the interaction between conservation interventions and different types of human well-being. And they scoured the scientific literature, coding out thousands upon thousands of scientific studies using a standardized set of parameters to generate this table. And what this table is showing us is kind of a map of where there is rich evidence and a map of where there is poor evidence. So darker colors mean there's more evidence, lighter colors mean there's less evidence. And as I say, this might not look like much, but what this does for a decision maker is both tell them what's been well studied in the past and what hasn't, but it also provides a potted reading list for people to, rather than have to scour thousands and thousands of studies themselves to figure out what's relevant, they can look at 200 studies or 25 studies because the work has been done for them. The same thing on the right-hand side with the conservation dashboard that we use at WWF. Here, what we're trying to do is rapidly synthesize data from WWF's initiatives and put it in context of the goals that we seek as an organization and the context of broader decision-making and global agreements that I spoke about earlier. And so here the idea is that it's not possible to get a standardized handle on the impact of work across a big portfolio of projects. You need a tool that helps you distill that down in a format that makes sense for the decision maker who will make the decision. So what does all this mean for this event and for the future of the planet? Well, I'd like to give you a few reflections for me about the road ahead. And I will say that no presentation from a WWF presenter is ever complete without a beautiful picture of elephants or pandas. So there is my obligatory beautiful wildlife photo. So what do we need to do to create a sustainable future that is driven by data? First of all, there needs to be a concerted and coordinated global effort to address critical data gaps. We need to know what the gaps are and the type of gap that we're dealing with. Some gaps, there's just no way of collecting data on the phenomenon we're interested in. Some gaps, there's just no way of collecting data rapidly enough or at a spatial scale that's big enough. These different types of gaps have different types of solutions. We need new ways of being able to harness data. If you think about the fire hose of information that we all live under, how do we begin to harness that and synthesize that in ways that are compelling and enable us to make decisions? And in many cases, it means we need new ways of visualizing data because we need to be able to see the phenomenon and let the data tell us its story rather than have us project our assumptions onto the data. We need to recognize that innovation isn't going to come in this space, isn't going to come from the people that we've always spoken to and the partnerships we've always had. It's going to come from those unlikely partnerships forged over cups of coffee or virtual chats with people who work in wildly different disciplinary sectors and who think about data sources really differently from us. One of the most fun examples of this that I've come across is a group of researchers who have been working to use data from OpenTable, which is a restaurant reservation website, and satellite imagery of hospital parking lots to predict hotspots of seasonal flu. This is an incredible mashup of seemingly unrelated data that tells us something useful about a phenomenon that is otherwise really hard to get a handle on. To tackle the loss of nature, to tackle global change in climate, we need to do more and more of that, and better and better. And so we need to talk with people outside of our spheres, outside of our disciplines, to figure out what data sets exist out there that we don't even know about. I think really importantly, we need to start moving beyond looking backward and thinking about the world as it exists now, to begin to move into a place where we can begin to predict the future, and not in a, this is exactly the future that will unfold before us, but this is the range of possible futures that will unfold before us. And that's really important because we increasingly know that the past is no predictor of the future. So how do we use the data that we have to think about what's plausible and what actions might set us on a pathway for the future that we are most interested in creating? The old stumbling block of sharing data and proprietary knowledge is an incredibly difficult barrier that we all need to cross, and we need to cross it soon. We need to recognize that shared data allows others to make use of things in ways that we could never envision, and to solve problems that are not the problems we seek to solve. So we need to share our data, we need to share our code, but we need to do so in a way that respects the underlying sensitivities in some of the data that we are working with. Those sensitivities might come from ethical concerns about revealing the identity of individuals. It might come from ethical concerns about revealing the location of highly endangered species that might further exacerbate their decline. And we need to fundamentally design for systems to talk to each other. In many cases, we design databases and visualizations in such a way that they're warehoused in a silo and they can't be discovered by other people, and they can't be linked up into other systems. And so rather than making interoperability an afterthought, it needs to become our core driving principle. And I wanted to end here with some reflections on some broader work that we've been doing to think about how do you create systems change, and what is the art and the science of creating large-scale transformation? And what are the principles that we all need to bring to bear, both as individuals, as teams, as organizations, as we try to grapple with some of humanity's greatest challenges? And this set of principles that you're looking at here really comes from a body of work conducted by a group called the Fuller Transformation Collaborative, which was an interdisciplinary group of systems thinkers, scientists, practitioners who came together in the dark days of a Washington, D.C. winter and locked themselves away for a weekend to think about what does it really mean to create systems change. And from those conversations, we distilled these 8 principles. The first one is that you need to see yourself in the system, and you need to understand that the world is not separate from you and you are not separate from it. You are reacting to it just as much as it is reacting to you. And so thinking about how you co-create in a world that responds to you and modifies itself based on your actions is critical to being successful. The second principle really speaks to the frames and the biases that we all hold. We all approach a problem with a specific lens, whether we know it or not. And so being able to identify and surface what those mental models are enables you to begin to have conversations with others whose frame is really different to yours. Co-creation needs to be, again, at the heart of what we do. It cannot be the afterthought. We cannot design in silos and then hope to partner later. We have to co-create and do it with care from the beginning. we need to think really carefully about how we think about time and scale. So some solutions may be adaptive and useful right now, but they might lock us into a trajectory that undermines our long-term goal. So as we're designing the future that we want to see and designing tools that can help us get there, we need to think about both their function and their purpose now, and their function and their purpose in the future, and think about that across scales. It's really easy in a complex and rapidly changing world to become just overwhelmed by the complexity. And this principle of finding simplicity on the far side of complexity is really simple to say, but much harder to live by. But the reality is, if we ignore the complexity of the world, our solutions won't work. So we have to find a way of grappling with that and using that. We need to experiment iteratively. We need to think about how the solutions that we bring to the table align the structure that we live in with the changes that we seek. Change doesn't work if we butt against the structure that we're living in. We need to figure out how to work within it and change it from within. And finally, we need to act based on evidence. So as we begin to think about how to move forward, we need to recognize that has gone before. So how do we save a planet? Well, we do it one data point and one line of code at a time. And so I'm really excited to see what all of you come up with during this event, because it really does change the world. Thank you.
Thank you so much for your time, Louise. This has been an absolutely mind-opening presentation, even for me, sitting here feeling incredibly inspired. So I hope for all the participants that are listening in that you were able to learn a few things about WWF and how they approach their work and using that systems thinking, which I'd love to see at our hackathon as well. So again, thank you so much for an amazing opening keynote. And if you do have questions, go ahead and head to the Slack channel, Ask Speaker Questions, and type your questions in there, and Louise will float for a little bit and answer those. But again, thanks everyone for your time today.
Thank you.